Hi, welcome to another tutorial. This one's demonstrating rotary encoder to set the min-max temperature for an alarm and just plotting the temperature on like a graph type display. You can see the real temperature up there to 3 decimal places. You can have it in 4 if you wish. I'll show you the code later. So all this is doing is for every second it's placing a dot that relates to the actual temperature. When the temperature goes off the scale, I'll just change where the position starts. I think this every 5 or 6 minutes this display will update and clear and start again. So it gives you a trend of the temperature going up and down. So it's written in MikroC, and I'm using the PIC 18F45K22. Right, I'm using the rotary encoder. Hopefully my brother, this is for my brother's side anyway. Hopefully my brother will put a link to the rotary encoder program I've got. I'm using the Dallas 18B20 temperature sensor, set to 12 bits. Right, better hurry up before this video runs out of time. Right, so you see it's just done 5 or 6 minutes and it's refreshed, so haven't got the temperature anymore. You can put it in there if you want. You can put graduations for X and Y axes. This is running about, you see, 21 degrees. So what I'll do, I'll stick it in the freezer. And you see the temperature starts dropping straight away. When it hits minus, you'll see the minus sign pop up, and so it's gone off the scale, and now this is, I'll show you the code, is where it starts plotting from the middle and then gives you a negative temperature. Unfortunately, if this was to go positive again within 5-6 minutes, this minus is going to stay there until the display refreshes. I'm looking to see if the temperature is positive or negative going, and then I'm putting a minus there. And the way I've got the screen set up, it doesn't refresh the screen because I want to keep the trend of the temperature. So you can see it shot down, and now we're seeing it display along there. So what I'll do, using this rotary encoder, which as I say will be either on my channel, if this video is on my channel, or for my brother's channel, which he's asked me to do, you'll see a link to this rotary encoder program, which I've done previously. So turn the encoder one way, counts up, press the button, starts counting down. Right, so I'm just turning this encoder, and I've got the maximum temperature alarm set as short, assigned short. So when we get to 0 and below 0, you see it goes -1, so for negative temperatures. So if I set it -15, say, well, I'll take the temperature probe out of the freezer, and you see the temp alarm's gone. So now we've got -4, -5, whatever, which is obviously greater than -15. So what I've done in the code, if I just zoom out a bit, you see, hopefully if I turn this light off, you see this port has come on, so this could either turn a relay on or off, or fan on or off, depending on what you're controlling, or you can just use it to control a heater, whatever you want. So when the temp alarm goes, this LED turns on. For those of you who haven't seen my other video, by the way, this Microelectronica's EasyPick version 7 board, I got it direct from Microelectronica, had to pay import tax here to the UK. This board's now available from Farnell Components for about £99 from Farnell. Right, back to the temperature display. The temperature alarm is still going, so if I increase the temperature, and you see we've changed graphs again. So it's gone off the scale, started a new plot, new trend, gone off that scale and coming up at the bottom. Well, when this temp alarm's going, everything's slowed down, so this rotary encoder is slower to respond. There we go. So you can see it counts quickly once we're not in the alarm loop. And press the button, we can drop it down. But what I'll do, put it right up. Goes up to 127, 128, which is obviously the max in assigned short. So because it's plotting a graph, not updating 5-6 minutes, you can see the temperature alarm did go, and now it's just refreshed. And it's still plotting slowly. So what I'll do, I'll put this temperature probe on my soldering iron stand. There we go. So this Dallas temperature probe would go, excuse me, minus 50 to plus 150. Well, actually, it's gone off the scale, starting a new one. I think I've got 3 temperature variations for between like 0 and sort of 48 degrees and 48 up to 80, and then 80 to over 100. But as you can see, we've gone off that scale, started a new one, gone off that scale, started another one. So this is obviously the maximum and last scale I've set. As you can see, you can put your own graduations in there if you want, but this is just a demonstration for the program, where you can see it levelling out now. Well, I've got to hurry up, otherwise we won't get the code in. Well, you can see that's levelling out. And the minus alarm's gone, and obviously the minus symbol's gone, but if we come up to 106, then that alarm's going to go again. Turn the soldering iron up. And there we get the temperature alarm, and the LED are set to power up any device for audible warning or turn the relay on or off. Hopefully I can edit the movie and tag this on at the end. So if I just scroll down, you can just simply copy it out, pause the video, and so this is a void display. So this is showing the temperature at the top left hand corner. And this is what I've added. If the temperature goes negative, we're saying the minus bit equals 1, and then GLCD write text, I'm putting the minus before the numbers, otherwise it equals 0. This is the temperature hole, which I had in a different program, just showing the temperature to no decimal places, just whole numbers. This is extracting a temperature. Actually, I forgot to mention at the top, temp resolution. This Dallas 18B by default is a 12-bit, so depending on what temperature sensor you're using, you need the temp resolution here, and then part of the code later on, you'll see temp resolution equals 12, and then to extract the temperature resolution bit for the maths, we're using a shift minus 12, or 8 minus 12. You could actually put a 4 there, but, and then later on, temperature right shift, and then res shift, which is temp resolution minus 8, which is actually 4. So you could actually put a 4 here, but leave it like that, and you can use different sensors. That's the text for the GLCD. That's rising. The tens and ones, and then the fractions of the temperature, and you see I didn't have the 4th decimal place, sort of rim that out. That's a whole temperature which we need for the maths, for like an alarm. So you see if temp's greater than 100, GLCD write text is putting a 1 in front of, like if it was 99, Goes over 100, puts a 1 in front of 99. Interstring, if you wanted this, you could put that on there. That would just give you the whole numbers, no decimal places. That's the bits for the max, just plotting the max temperature. This is the counter, so it's plotting dots. When it gets to 1280, clears the screen, resets the counter, start again. This is for the code for the alarm. So if the whole temperature is greater than max 1, so write in the temperature alarm, delay for 600 milliseconds, and then writing the temperature alarm, but in a negative colour, so it's effectively clearing it, and so that bit's flashing, and then it turns on RC7. This is the capture. As I say, hopefully my brother will put on a link to my capture code. So this is capture 1 and capture 2 for the rotary encoder. This is just showing the graph. That's all that's doing, showing the graph, and for the various temperatures it's starting to plot the dots in different places. You've got a delay for normal temperatures, so it'll plot it slowly, and I haven't put the delay for the higher temperatures so it counts quickly. Gives you a better resolution on the screen, and then every time it's done that, counter 1 equals counter 1 plus 1. This is the interrupt for my rotary encoder. When I press the button, it changes direction, goes positive or negative. This is the RB interrupt flag, change on interrupt. Bit direction, that's for the rotary encoder, and then void main, counter 1, 0, so that's the max flag we're setting initially at 0. Capture, all ports digital, the global peripheral interrupts. This is the interrupt on change for the press button on the rotary encoder. Other various bits, various ports inputs. CCP1, so capture enable, capture 2 enable. Disabling comparators, with a capture on the rising edge or falling edge, and then writing the display. And this is a while loop, so it's constantly looking for the rotary encoder. And you can see max plus 1 increments the max there, or decreases it there. And it's looking if it's going positive and negative, simply writing a 1 or an 0 to the EEPROM register. And then the program is looking for that here direction, equals EEPROM read. And then this is, in the while loop, this is looking at the temperature display itself, or sorry, temperature sensor. Meant to have quite a big loop. If you're doing a 12-bit conversion, it's meant to take something like 800 milliseconds, but then it slows the encoder down. So I put 20 millisecond delay there, and it seems to work fine. So, and that's the end of the program. So hopefully this has all made sense.